Good evening, everyone. Thank you so much for joining us this lovely spring evening, and welcome to the Win-Win Startup Showdown here at the Housing Works bookstore. It is an absolute pleasure to spend the next couple of hours with all of you and with all our finalists for the Offshore Wind Innovation Hub Accelerator Program. I'm going to try and change the slide. There we go, because that's me. So my name is Tone Sondergaard, and I'm the director of the Offshore Wind Innovation Hub. The Offshore Wind Innovation Hub is the newest program under the Urban Future Lab umbrella. Our mission is to catalyze innovators and unleash the potential of offshore wind. We leverage our hub in Industry City to create and grow the US and New York offshore wind industry. We do that by creating collaborative partnerships and advance an inclusive supply chain to accelerate the green economy here in New York City. And last but not least, we are also a co-working space and a community for the offshore wind industry. Tonight, however, is all about our main program, which is our accelerator. We have worked hard over the last 6 months to scout for the most promising and most innovative solutions out there. I will, however, say we have not worked hard as much as the 11 finalists who you're going to see on stage today, because they have truly worked for years in order to be able to stand here tonight and pitch for you all. There we go. We had applicants for our accelerator program joining us from all over the world, and actually from 3 continents, flying in just to be with all of us today. And as you may have known, we were seeking startups within 7 different focus areas. These were production optimization, site selection, surveying and data collection, site constructions, power transmission, safety improvements, and supply chain development. And I can promise you all, you are in for a treat, so please get excited to see our 11 finalists pitched for you today. Give them a hand. But of course, there is no good pitch night without a jury of esteemed experts. We have 5 of them with us tonight representing our partners from the Offshore Wind Innovation Hub. And essentially, I'm going to start maybe from the inside out. So Lindy Hayes Dunton, you are the Executive Director of the National Offshore Wind Research and Development Consortium. If you take a microphone, then maybe you can tell us, what are you looking for in today's pitches?
Hi, I'm Lindy. Thank you everyone for coming today. So the R&D Consortium, we support research and development to kind of accelerate offshore wind in the US. So we're into research and I'm a scientist. So for me, I'm really looking for our startups and our companies tonight to tell us about how they are using creative, innovative solutions to support R&D and kind of science-based solutions for offshore wind. Thank you.
Thank you, Lindy. And next up, we have Parker Malone. You are the investment manager for Equinor Ventures. What are you looking for tonight?
Yeah, thanks so much, and great to see everyone. My name is Parker Malone. I'm really excited to be here. Equinor Ventures invests broadly across the energy and carbon nexus. What I'm looking for are strong and collaborative teams that are really willing to roll up the sleeves and get to work on what I think is an incredibly exciting opportunity. So really want a strong team with the right partners, with a distinct value proposition working in a scalable market. So that's enough buzzwords for me, but hopefully that gets the idea across.
Wow, amazing. Thank you, Parker. And next up, our own Pat Sappensley. Welcome. You are the Managing Director of Clean Tech Initiatives at the Urban Future Lab at NYU Tandon. Pat, I know you've seen a lot of these over the years. What are you looking for tonight?
So because I've seen these from the VC side and from the incubator side, and because I know my esteemed colleagues are looking at the technology and the financial stuff, I want the the startups, to know that the other thing we're always looking for, if we're VCs, if we're an incubator head, if we're a customer, a channel market partner, we're looking for a team that has integrity and that's coachable and that can work with you. We're not looking for arrogance, especially when you answer the questions. You have to show that you're someone that this investor or this incubator will want to work with. So you have to be coachable, you have to have integrity, you have to prove that if something goes wrong with your technology, you're going to be a stand-up individual and say, here's what happened and here's how I'm going to fix it to all of your customers, to your investors. So keep that in mind.
Amazing. Thank you, Pat. And next up we have Arturo Shuruk-Dishan. You are the facility manager of Beacon Wind from Equinor. So what are you looking for tonight?
Thank you, Tony, and glad to be here as well. I'm more in the execution part of the offshore wind projects, so I'm really looking forward for the team to show ideas that are going to be realistic, fact-based, some ideas that we can actually see in the wind farms in the future. How can you collaborate here in New York City, which is something that I consider the capital of the universe, right? It's a melting pot of all cultures and disciplines, so definitely be calm, be excited. You guys have done a lot of work to be here, so just have fun and tell us what you're up to.
Amazing. And last but not least, Melissa Roman Birch, you are the Chief Operating Officer for New York City Economic Development Corporation. A pleasure having you as well. What are you looking for?
Thank you for having me. It's a real pleasure to be a part of this inaugural pitch event. Wind-win, I love it. I'm actually looking for win-win. I'm really looking for teams to talk about partnerships, partnerships that they are looking for from New York City, partnerships from community, and partnerships with other business, particularly as we think about the supply chain. So that's a big word for me, partnerships, and how are you going to collaborate in the process of bringing these new technologies to bear. Thank you for having me.
Amazing. Give our judges a warm hand. And then it's actually my great pleasure to, from here on out, give over this microphone to a man who is way more used to doing this than I am. So please welcome our MC for tonight, Harris Alterman, to the stage. You're here. Welcome. Harris was selected to be part of the inaugural climate comedy cohort. His sketch videos have been watched more than 45 million times. I guess some of the pitches tonight might try and see if they can beat that one. You've been featured on Comedy Central, and of course you performed at numerous festivals, but tonight you're here with us. So thank you so much for taking us through this night from here on out.
Thank you. All right, have a round of applause for Tone, everybody. I think that's the first time I've been introduced while also standing on stage. This is nice. This is the first time I've performed at something quite like this. Usually I'm performing in like dirty dive bars, so this is a change of pace. You're all very polite. That's nice. Feel free to smile, you know. It's okay to smile, you know, you can uncross your arms. We're gonna have a nice time. The reason they asked me to host is I'm a comedian, and they told me that usually the people who host these type of events are what's known as Dougs, doughy old utility guys. That's what I was told. So I am not a Doug. I am a Harris. I am a hunky, agile, really, really intelligent speaker. So a little bit of change of pace for you. And I'm very excited to be introducing all of these amazing offshore wind projects while we still have shores, you know. We take shores for granted, I think, you know. Honestly, I think we should tell the public, you know, like, hey, you know, onshore, where you live, if we don't invest in climate change, energy solutions, that's going to turn into offshore, okay? Do you want to live offshore? No, you don't want to live underwater, do you? That's right. I think we take shores for granted. Every night in my gratitude journal, I write the word shores, okay? I hope you're all doing the same. So yeah, very excited to be introducing these amazing offshore wind companies and ideas. I know some people out there have expressed skepticism about offshore wind, including climate activist Donald Trump, who said, and I swear to God, this is a real quote, he said, windmills will kill many, many bald eagles. It's true. Let's break this down. Okay, first of all, I find it very strange that he's so concerned about the life of birds and at the same time eats KFC every morning for breakfast. Hey, maybe if you're so worried about birds, don't dip them in barbecue sauce. I don't know. Like, you know that if KFC released eagle nuggets, Trump would be like, these delicious. We have the best tasting eagles. These eagles are tremendous. Also, I'm not sure you picked out, he said windmills. I think he meant turbines. He probably saw the windmills on like hole 14 of the Mar-a-Lago mini golf course. And he was like, these are too small. How are these going to produce clean energy? They're too small. They're too small, you know. That's why we need big solutions, you know. Because as I'm sure, like many of you, personally, I'm a little sick and tired of feeling like I have to solve climate change with all of my tiny little day-to-day choices. You know what I mean? I'm tired of it, but I try. You know, we all try. We're all recycling. I'm composting. I'm eating less meat. You know, it's not enough. I've been conducting a series of my own carbon offsets, okay? Every time I drive my car, I get out of my destination and I slash the tires of the car next to me, okay? I'm trying to help. If I leave my living room lights on overnight, I cut the power to my neighbor's house. I'm trying to help, okay? But my individual efforts and all of your individual efforts, it's not enough, is it? It's not enough. We need big ideas, we need big companies. So that's why tonight you will hear from 11 finalists who are competing for acceptance into the Offshore Innovation Wind Accelerator Program. There's about 1,700 words in this thing. I think I got close though. And they are competing for a chance to gain acceptance into the program where they will get mentorship and guidance on New York City supply chain and given the tools to succeed in this rapidly expanding market. So let's go over the ground rules for this evening. So the format for this event, each speaker is going to come up here. They're going to be given 3 minutes to present, and we will follow that with 5 minutes of Q&A from the jury. Jury, feel free to just start rattling off questions right after they end their presentation. You don't need to feel like you need to be prompted. And we'll also not be taking any breaks throughout all of the pitches. So if you do need to use the restroom or want to grab a refreshment, please feel free to do so as needed. Sound good? Yeah. Okay, let's kick this thing off then. It is my pleasure to introduce your first speaker of the evening. She is representing Bedrock Ocean Exploration. Please give a round of applause to Bridget Bolahanis.
Thank you so much. You can hear me, yeah? Great. Hey everyone, my name's Bridget, and I am here today to talk to you about Bedrock Ocean Exploration. Bedrock is one of those companies where the heart of what we do is right there in the name. We're here to explore the ocean. Currently, humanity knows more about the moon and Mars than we do about our own ocean floor. Bedrock's mission is to change that, starting with this little guy you're seeing on the screen here. This is our custom-built autonomous underwater vehicle for seafloor mapping. It's called an AUV for short. Basically, you can think of it as a self-driving car, but built to map the ocean floor. We built this vehicle because we believe that, we can change slides. We believe that humanity needs to start thinking about ocean exploration as a technology problem first. Bedrock has the technological team with the deep expertise necessary to solve the main challenges in seafloor mapping. The way I see it, there are basically two main challenges to getting a complete ocean map, which is our mission. The first is, we gotta map it. There's a lot of ocean out there and not that many ships. So how do we solve that? The second main problem is actually a data problem. Let's say we map the entire ocean floor. That's going to generate a lot. I'm talking petabytes of data. Storing and managing that data in an accessible way could really quickly become untenable. We don't want that. That's why Bedrock has, from the start, been built to be a vertically integrated, modern technological solution to these challenges. Everything from our AUV to our web data platform for sharing has been custom built in-house to be a modern solution. Because you have to keep in mind that while it's really clear to all of us in this room here that offshore wind is going to be an incredibly important part of the global energy market, oceans are going to continue to be an important part of disaster risk and mitigation, as well as critical infrastructure in the decades to come. Oceans are going to continue to be important for us. So we need to bring our understanding of them into the modern age. Currently, surveys are being conducted generally with large ships with full crews that are deployed for months at a time, often dragging sensor suites behind them. These ships are loud. They use traditional fuel that's emitting literal tons of carbon dioxide into the atmosphere every year. And they cause severe risk to marine and especially human life. It just doesn't make sense that we're still doing things this way. Our solution is to deploy our custom-built AUVs. They're around 7 feet long, weigh about 130 pounds, and they contain all of the sensors that you need to make a beautiful seafloor map. They can be deployed from anywhere, and they're small and so high frequency in sound that they pose absolutely no risk to marine life. Once they're deployed, they do everything for us. We can just sit back, relax, and wait for the data to stream in. And for that, we've built our own, wow, these slides are not under my control at this point. I'll be real with you. Point to you. Can we go back one? Thanks. So we've built our own custom data platform for storing, managing, sharing, visualizing, and analyzing this data. It's all live in the browser and easy to use, which is great because you're going to want to see our data. This is some of our awesome data that was recently collected using our AUV. Now, what you can see up here are sand ripples, some boulder fields. They pop right out of the screen. Now, for me, who is a certified PhD in being a data nerd, this is exciting enough. But imagine data of this quality going over a critical pipeline or an unexploded bomb that you'd really like to know the location of. The value of data of this quality can't be overstated. Bedrock has a proven out solution that is vertically integrated to figuring out how to map our entire ocean floor. And we're currently building out a fleet of vehicles to do exactly that. We believe we can meet, if not exceed, the needs of the current offshore US wind markets. At Bedrock, we believe that the ocean is our future and the future is now. Thank you.
So interesting. I can't wait to see these maps. My question for you is, just first I'm curious, you caught my attention with why the ocean is so unexplored relative to places even like the moon. So why is that? And two is, what are the other types of industries other than offshore wind that you think need to have this level of mapping and information?
Yeah, absolutely. So why the ocean is not well explored, it's because it's hard. I'm not gonna get up here and say like, it's easy, we should have done it 20 years ago. It's a challenging environment to work on. It is in fact a much more challenging environment than near space. And part of the reason that we have explored near space, I mean, there's a few reasons. It catches people's interest. Everyone loves looking up at the stars, right? But another reason is that we've got light. And light is a really helpful tool. You can take far photographs and telescope images and measurements of nearby planets. But light does not penetrate into the ocean very far at all. And that's why we have to move away from this idea that, you know, you're not going to look down and say, oh, yes, I see an underwater volcano. Instead, you need to be using modern technology to make those maps. And so our tools are using things like sound waves in order to illustrate what's going on the seafloor, not depending on technology that would work for something like space. Then in terms of other markets besides offshore wind, I mean, one thing I have to say, just because of who I am, is there's an inherent value in us understanding the ocean floor. My background is that I have a PhD in marine geophysics, and the reason I came into this is because there's incredible risk associated with the seafloor, right? Seafloor motion has caused the loss of millions of lives. And so understanding the disaster risk and how to mitigate that in mapping the seafloor is both imperative because we're humans, but also in terms of disaster risk mitigation, that is a financial market. There's also, of course, traditional energy needs that use offshore, and I'm sure many others will be coming about in the coming decades, such as deep sea mining.
Can you talk to us about the durability of these things in a harsh ocean environment and also the range? You know, you have, I'm assuming these are battery operated. So how long can they stay out? And, you know, what does the ocean do to them? How long does it take for the ocean to destroy them?
Yeah, absolutely. So we're a relatively young startup. That's why we're here. But so we haven't pushed this thing all the way to its limits. We have never had a vehicle destroyed yet. It's going to happen eventually, but it hasn't happened yet. I will say that we have pressure tested our AUVs, and we go through a pretty extensive factory acceptance testing process in building them. And so they can stand up to like pretty much normal, if not more extreme, ocean conditions. We don't have any reason to think that just general wear and tear of being in the ocean would degrade them any faster than any other ship or other material that's in the ocean, and they would require, you know, regular servicing. Each AUV, in terms of your battery life question, each AUV has a battery life of around maybe 12 to 24 hours, depending on the number of sensors you have running at any given time, and also conditions, right? With each AUV, the way that we've designed it is it essentially pulls apart in half. You can pull it apart on a ship, anywhere you are. It's not hard. You don't even need a screwdriver. The back half contains the computers and the battery. The front half contains all the sensors for mapping. So basically what you can do is deploy it, have it come back, break it in half, plug in the new battery, send it back out again immediately. While you charge the other one, you upload the data.
As a follow-up, how would you deploy it? Will you have a vessel, probably a small vessel offshore, and then do that process? Because I guess from shore you can't operate it. Is too far, or is that possible?
So we're flexible. Because it's completely autonomous, we don't need to have eyes on it at any given time, right? So we can deploy it from shore, from a dock, from a boat. Right now, when we're doing testing, we're launching it off of a small dive boat and kind of letting it do its thing. When it comes back, we pull it up. It doesn't have the kind of stringent requirements that a lot of other instruments like this in the industry do have.
Thank you. Keep it going for Bridget, everybody. And I do want to let the standing people know that we do have many chairs over here. If your legs get tired and if you like sitting down, that is an option to you. I'd now like to introduce our next speaker from OSC. Please, a round of applause for Jürgen Dronen, everybody.
Okay, hello. Yep. My name is Jørgen Dronen, come from a company called OSC in Ålesund, Norway. So what we are is that we are a market leader in virtual prototyping, basically also delivering digital tools for helping customers and users to basically optimize and test out their real engineering solutions. In the offshore industry, we have roughly 3.75 deaths and 473 accidents on a yearly average. This is way too much. What are the challenges? Basically, everything needs to be bigger, better, and faster, meaning that we are installing bigger turbines, we need bigger equipment, we need bigger vessels. Everything needs to be better in terms of the methods. Everything needs to happen faster, and everything in addition needs to be cheaper. How can we help with this? So basically what we help with is that we de-risk projects, we quantify the unknowns, we help to optimize the work methods, we can train and increase competency enhancement, and we can prepare for future operations based on real data and real sea and weather conditions. We have a trusted solutions. We've been doing this for more than 15 years. These are just some of the names that we are working with. We have delivered simulation solutions to basically all around the world. We are using virtual prototyping to help our customers basically to test out their engineering, their design reviews, everything in a digital environment. Some of the pictures here that you see is in our simulated facilities. So we have a full simulated environment where people can do their verifications inside safe environments, meaning that they can build trust in their solutions and test out everything in safe environments. We have delivered simulator centers or competency centers around the globe, basically in the UKs, in Norway, in Brazil, in Singapore, and in Australia. We're just missing the US, as you can see. But what we want to do is that we want to establish a US, maybe New York-based competency center where we see that simulator facilities is a key asset, meaning that we can create an environment for companies to cooperate, to partner up, and actually test out and verify their solutions. Thank you.
Hey, good to see you again. We had the pleasure to talk this morning a little bit, but I want to stress the importance of moving quickly as we are going and expanding, call it the deployment of these technologies. We're moving at breakneck speed, literally, and so I'm just curious, how quickly can you deliver on these projects, and then what does that time saving look like for the end consumer?
Yeah, so basically, as I mentioned, this is like quite known to us. We've done this before, but when it comes to like setting up a type facility like this, it tends to take like something, let's say, between 2 to 4 months before we're up and running. And what we kind of provide is that we provide the platform, the simulator facilities, the technology, and the software, and then we like to partner up with like local companies to help us actually like conduct the training, to conduct the competency enhancement, and also like external companies to come in and actually test their solutions. So but when it comes to time saving, often we say that we historically we have a 20% return of investment, and we say that that can either be like a risk reduction or time reduction, basically. So.
Hi, you're in, I think I caught it, 15 years of experience in countries all over the world, but not in the US yet, and not in New York yet. So what do you anticipate you might experience that is different or unique about New York City and the US market, and what sort of New York City government or municipal support do you think would help you set up operations?
Yeah, so what we see is that US has been a hard market for us to kind of penetrate, and it's hard for us to kind of serve that market from Norway. So we definitely feel that we need like a hub of operations, and we definitely feel that this program could help us accelerate that and expand our market and actually, yeah, get good partnership and networks to actually spread our technology and solutions.
Excellent. Excellent presentation.
Well, we know each other, OECD, Equinor, for quite some time.
Yep.
Have you thought of using this type of technology to train the next generation? For example, in the universities, in certification programs, in the new workforce, the workforce of the future, the workforce that probably has not even been born yet, right? How's your discussions with the academia and entities like this?
Yep, a good question. So we've been in contact with a lot of the local academia and universities here. We're actually a spin-off company from Norway's biggest university. So we always partner up with the university. And I definitely think that something like this, like a digital platform, is the way to go for like future generations, the PlayStation generation, as we can call it. So I think that's definitely a positive thing. Yep.
keep going for Jürgen, everybody. And just a note for all of the future speakers, if you're having any problems with the clicker, if it's not working, just point at the back to the guy waving his hand and he'll change the slide for you. I'd like now to introduce our next speaker from Harima Engineering Solutions. Please, a round of applause for Silvan Slypan.
Thanks, Harris. Really excited to be here today to tell you a bit more about offshore construction planning. So we started Harima Engineering Solutions around 4 years ago, and we started looking at the problems in the offshore construction market. And what we saw is that a lot of companies are still planning their offshore construction with an asset, around an installation asset. And if you look at that and you look at the construction of an offshore wind farm, then you'd realize quite quickly that it's an oversimplification of the planning, because you will not cover the complete construction process, which contains a lot of activities and items that are happening around the asset or on a yard or somewhere else, and that are not properly covered. What in the end brings down your, or actually you underestimate the amount of cost that you will have during construction, and that might bring a risk to your profitability. So this is how a real project looks like. There's a lot of assets, there's a lot of locations, and there's a lot of activities happening. And all these activities, they actually interact with each other, they're depending on each other, and when one of these activities is delayed, that will have an influence on other activities. For example, if you install an offshore foundation, a monopile, and you want to start driving that monopile, you first need to clear out the seabed, make sure that you can actually put some scour protection there. So then you have the scour protection installation asset that you need to bring in. You need to put the scour protection. But before you start even driving the pile, you need to bring in your noise mitigation system, which is also a set of assets that you need to put in place, and that is that all need to work correctly together. On top of that, you'll have risks. There are 3 types of risks that we have identified and that are typically your construction process is prone of. First of all, it's weather. So your weather will result in weather downtime, waves, wind, current. That will delay your construction compared to when you would not have any weather. Next to that, you have the ecosystem and the laws around it. For example, if a right whale shows up, you'll find that you need to stop driving your piles, otherwise you will harm its ears. And next to that, you also have human failure or human error and equipment breakdown. All these risks are not covered in normal construction schedules. However, that's why we built Metis. Metis is basically a software set where you can, a software suite where you can put in all these risks and the complete construction schedule with all the relations. And this software allows you to actually understand where your risks are and how they affect your construction schedule. So you will be able to understand exactly what's going on during construction, how you can improve the efficiency of your construction, and you can also de-risk the construction. So when you see, for example, that one of the assets has a is highly affected by weather, you might change the activity the asset is doing, or you might exchange the asset for a less weather-prone asset. So this is Metis, and this will really help you to properly assess the construction or the construction duration, so your schedule, in a good way, and help you build trust in your cost base. And we think that within the US market, there's at least 30 projects where we can apply this software on and support developers to assist them with building the right cost base, keeping track of their construction process. So, sorry.
So thank you for that. In order to understand the value that you're bringing to this process, we need to understand the differentiation between what you're doing and what other engineering firms are doing. I find it hard to believe that they don't have a risk management process built into their engineering as they're going through all of this. Can you explain to us what is so different about Metis?
So what's so different is that we are capable of basically running a logistical simulation where weather downtime and other risks are included in the simulation. So it's one suite that allows you to assess your risk on your construction schedule, and you have both the construction schedule completely modeled and the risk within. And currently there is only one competitor in the market that is providing this solution, but they're not yet flexible enough to cover all different scenarios. Because offshore construction is very complicated. Every location, every project has certain boundary conditions that you need to take into account. Our company has been working on offshore construction and understanding offshore construction based on our sister company that's already doing this for 50 years. So we took that knowledge and we try to support developers and other clients that are interested in the supply chain and offshore construction to help them to understand how to do it. And that's why we think that this software is really adding value to the industry compared to the other softwares that are currently used.
Great point about what are also the things that will also not only differentiate yourself, but how do you market your product? This is a software that you will need to provide as a license, or you actually have to have your people in the developer offices developing this solution to be customized?
No, so what we try to do here is to have actually a hybrid solution there. We think a lot of developers have in-house knowledge to run this software to a certain level, and sometimes they might not have sufficient resources, or sometimes they are trying to get a new development or innovation in their project. And then we aim to be able to support them with that kind of questions, update the software, make sure that it fits their needs. So it's a customized software package that for typical projects and early quick assessments, they can use it themselves. And whenever they have a more complex question, we come in and we are there to support them and make sure that they understand the risks and really get a grip on how the construction of a new technology will look like.
So long, everybody. And now please keep that clapping going for your next speakers from Enduro Industries. It's Matt DePico and Sam Rousseau, everybody.
Cool, thank you. All right, good evening, everyone. I'm Sam. This is Matt. We're from Anduril, a California-based company. We're from the Massachusetts office. We'll go to the next slide. Cool. So we're here to talk about our autonomous underwater vehicle. So think like mini unmanned submarine. Next slide. All right, so how did we get here? Back in 2018, a couple of colleagues and I decided to start a company called Dive Technologies. The reason we did this was that we had deep industry experience in autonomous underwater vehicles. We found everyone was making smaller AUVs that could go out for, say, like 12 to 24 hours at a time. Meanwhile, customers were asking us to go out for longer range, longer endurance, carry bigger payloads, so carry the sensors that typically were housed by a towed array behind a manned surface vessel, but package those into a robot. So we needed to go bigger with the robot. We launched a company called Dive Technologies. We built a hardware platform. We then found that we needed to focus on the software piece, and there was a company called Anduril Industries that was very good at advanced autonomy, edge processing, things like this, and so we merged the two startups about 18 months ago. There's other products that we're building, like a hovering vehicle, et cetera, but we'll focus on the Dive LD today. Next slide, please. All right, so what does the Dive LD do? This thing is rated to go down to 6,000 meters ocean depth. We've taken it down to 3,600 meters. to collect data. It's rated to go out to for up to 10 days at a time. We recently were just out doing some testing for 9 days unattended. So these are things that like we typically see manned surface vessels do. Our goal is to be able to launch from the pier, go out, do these missions, and I think we created the vehicle to do that. We're also very adamant about our navigational accuracy. So we've got a big inertial navigation system that can get down, well, we won't drill down on the engineering details, but really tight nav accuracy, so all the things that you care about on the ocean, we know exactly where they are. A lot of payload flexibility, so we can package those sensors, and we can build these vehicles in just 30 days' time. So pretty quick turn on scaling these things. So as this market grows, as we want to augment that manned surface vessel fleet, we've got the vehicle that can do that rather quickly. I'll hand it over to Matt.
Thank you, Sam. Next slide, please. Why are we here? You look at what the White House has asked for the amount of offshore wind that needs to be installed in the U.S., 30 gigawatts. Last check, we had 7 odd, maybe 8 megawatts. So you're talking about a 4,000x increase in 7 years. Yeah, very minor challenge. Oh, and by the way, meanwhile, DOE goes, can you bring the cost down? Can you bend the cost curve? Find technologies, find people that can just help reduce the cost. We can't help reduce the cost of a wind turbine, unfortunately. But what we can do is we can help reduce the cost of gathering the survey data, getting out there, getting to a permit faster, and getting your turbines sunk into the ground, into the water, or floating offshore if you're in the deep waters of California or Maine. Next slide, please. This is what we're proposing for the Offshore Wind Innovation Hub. We're proposing to do pier launches of the Dive LD. Again, remember Sam said it has about 1,000-kilometer range, or up to 10 days. Swim it out to Empire Wind, turn on the sensors, what we call mowing the lawn. Just go back and forth, grab all that data, survey up all that data, bring it on board onto the Dive LD, swim it back to shore so you can go recover it off the same pier. While it's swimming back to shore, we're going to process the data and count boulders. Before you do any construction in the offshore wind industry, you need to know where your boulders that are 30 centimeters or a foot larger are on the seafloor. So as soon as you find that, you got to count those. Instead of sending back data and having a person sit on shore and go, oh boy, there's a boulder 1, 2, 3, 4. We're going to process that, bring it back using our autonomy algorithms from Anduril Industries. So the Dive LD gets back to pier, has all that big old chunk of data, and it even knows where all the boulders are. You can move faster, you can get into your permitting, you can submit your SAP survey, COP survey, etc. Next slide, please. This is what we've already been using it for. So we've been using one sensor, and we're really good at finding lobster pots. Cool. Yeah, at least you know what's down on the seafloor. We need to train our machine learning algorithms to move beyond lobster pots to rocks and boulders. Cool. We've done that already with some other more interesting to a different crowd defense equipment that we find on the seafloor as well. Next slide, please, Sam.
All right, so counting boulders, pretty awesome. I think our time is up, but the whole idea is that we can package a lot of sensors, so that's kind of just where we're getting started, right? And we're here to seek out a partnership so we can get this right, train our algorithms, but then there's so much more that we can do with the sensors that we're packaging in our vehicle. All right, launch.
The biggest challenge is getting everyone to figure out. There we go. Thank you. Thanks, Sam. Thanks, Matt. I think great presentation. I think one question I have, and I had the opportunity to kind of see your longer pitch today, so I appreciate that. Anduril is already really successful. Your platform is pretty successful. So why are you interested in the hub? What do you see the value of this program and the kind of resources that this might both bring to you and then what you might be able to bring to the industry?
What we get first and foremost is a partner in an offshore wind developer. We need them to, we're a bunch of data scientists, robot geeks, as it were. We're great at robots. Great. But what we really need to do is make sure the data is in an acceptable format, make sure what we're looking for is exactly what that wind developer or other wind developers are looking for out of this system and all the data it brings back. You can bring back gobs of data. It just doesn't matter if they're not what the customer or the wind developer wants to see. So that's what we're looking for, is that guidance, that ability to take what we already have and operationalize it. So what we think we can bring to the Offshore Wind Innovation Hub is a robust product, a robust platform that needs some tweaking on the edges to make it suitable and solutionized, I'll use a buzzword or something, for the actual offshore wind innovation industry.
That's right.
Question for you. Really interesting presentation. I'm curious, you said in 30 days you can build one of these. So where are they built? Can you talk a little bit about the supply chain? How many of them are needed to serve the projects in the New York area?
Okay.
And is there an opportunity for supply chain development within New York?
All right, so they're built in Massachusetts. The way that we get ahead of this is we stock all of our long lead items, but also when we designed the vehicle from like day one, it was designed for manufacturability because we felt that AUVs were interesting over the last 20 years, but it's now time to do AUVs at scale, and we want to be the company that does that. When it comes to like how we position ourselves in the state of New York, oh, you want to do this? Yeah. Matt is very eager to answer this, so we'll
Super excited. So the model lends itself well. We're talking about pre-construction right now. What we envision is multiple dive LDs, let's say 3, 4, 5, in a branch office down here in New York, operated by local talent that we build up. And for the next 20 odd years, that's a career for those people to operate the AUV, to maintain it, to make sure it's going out for operations and maintenance inspections. So it's not just come down here, let's get some survey data, let's put the wind turbines in. Okay, we're gone. Where are you? It's set up a shop at that time to service the equipment and run those 20 years of maintenance. So that's it's portable to other local areas in the United States. So,
Great,
yeah.
All right, thank you, everybody.
We lost the clicker. Oh, thank you. Keep it over there, everybody. And keep that call going to your next presenter, Abhishek Srivastuvu with Technobuilt.
Thank you very much. Just checking the clicker. Perfect. Well, good evening, everyone. I'm pleased to present to you about Technobuilt. Technobuilt is unifying people and processes on a machine learning platform that's accelerating infrastructure and energy projects. Now, if you look at the problem, 35% over budget is the current state of offshore wind projects, and they are running 2 years delayed. And as we do more and more of these projects, it will tend towards the industry normal of 80% delayed in the more complex projects that we are doing it. But we are here to solve this problem, and Technobuilt's platform is already solving it for the likes of Microsoft data center projects, to Exxon doing LNG, to Shell's $8 billion project that is now getting proven and validated on the platform of our solution. We are one of the rare tech companies that are cash flow positive pre-Series A. And the reason we have been on it is every project deserves a successful outcome for its end users. It needs to be delivered on time and on budget so we can use it. However, what ends up happening with the project manager when he's trying to deliver this, he's got tens of thousands of line activities that he needs to do. There are engineers doing the design, the fabrication is happening, the on-site installation. All of these are disconnected, and there's poor visibility in the whole process. And what ends up happening is that the 3-year wind energy project becomes 4 years, and the 500 million we have budgeted becomes 700. But take a deep breath. Imagine if we can do this better. Imagine if we can prevent all that cost overrun and delay through the Technobuilt solution. So the solution actually uses principles of containerization that connects all the way from concept to completion of all the information of that needs going to become a physical asset using a unique technologies that have been developed by our subject matter experts. Imagine shipping containers. It increased the capacity by 30 times of the shipping industry, and manufacturing became a global thing because of the efficiencies in shipping. And imagine what it can do to construction and productivity in the energy projects. The Technobuilt platform, as actually modular, goes from all the stages from advanced project execution to on-site to safety, on monitoring it through a digital control tower that is using machine learning to figure out what is going to get wrong even before it's happened. So we are mitigating the risk even before it surfaced through the platform. How does it, let's take a sneak peek at it, right? On this single screen, you are seeing $500 million worth of civil steel structure that is being executed. Through the reds and the blues, they know whether they are in design, supply chain, is there any issues? It's bubbling up right there in the yellow dot for your highlighting. On a single screen, we have been able to automate it. Imagine where we are taking this next. We all live in a ChatGPT world. What if project manager is going to ask, what's the status of the wind turbine 102 location? It's going to say it's the status as of today on schedule, but if the installation data is not received by next week, which we haven't, then we are going to be delayed. And James is the person working on it. Maybe you should expedite it. That's where we are taking this further. And we are applying this to safety. Very important that the safety is addressed with the machine learning, so we are de-risking everything through the AI of all the steps. Similar to permitting, all the steps that are going on live on the site. And then now finally we are able to reach a place where our clients are experiencing a 20% increase in productivity. And we are not only preventing the cost overrun, but actually saving some money over there. But the most important thing is up to 100% schedule certainty has been reached. I think New York State and the planet needs clean energy transition to happen quickly on time and budget, and our technology is here to make sure that happens every time. Thank you.
Hey, thanks so much. My ears as a VC certainly perked up the moment you said cash flow positive. So I think that's quite an accomplishment. I'm curious, what specific part of the platform is experiencing the most traction today? Is it the HSE component, the supply chain component? And then somewhat relatedly, this is a fairly generalized platform that you're porting into the different industries. So what's the incentive for an offshore wind developer to use this platform versus a targeted platform?
Great. So answer your first question. The health and safety modules are very easily adoptable. They're low barrier. It's a very offline process. If you look at the state of the art, it's doing very fast adoption in all our projects. The second one is the digital control tower. Really, no one has the end-to-end visibility that you just saw, and that you can figure out all that complexity with a single screen. Those are the two where we are getting the most traction out of. And regarding offshore wind, right? We are just learning as human beings how this technology is becoming more and more viable. We are actually at the surface of it. And as someone just said, it's 4,000 times X. We're going to do more projects like that. We need to learn and not make the mistakes again. And this is a machine learning platform. It learns the installation of each and every turbine. What are the faults happening? What are the installation happening? What was mitigated? And it is providing that information real time to other projects, to other areas of the project. So the more and more offshore wind projects we are doing, every time the productivity that we have reached 20%, I feel that can go to 50%. So that's why we need to do it now in offshore wind projects. Yeah. Thank you.
Quick question, then what is your business model? Do you sell the software or do you sell the engineering services and go to the developers to build this integrator?
No, so we build the integrator and the APIs. So we've got the 30 APIs to connect all of the siloed systems, and we license it as a simple subscription model per the size of the project. There is like a 6 to 8 week implementation time where the configuration and onboarding happens.
Can you give us a quick example of how it enhances safety, on the Equinor site? How would this be used to enhance safety and construction?
Right. So safety has got various modules. So there are safety assessments, management, compliance, and the monitoring of it. So all of these processes are right now quite manual. So they first of all become digital, and we have the mobility apps that capture the end safety information. In fact, there are some sites where we could not forgo paper because the paper safety process was still an important part of the process. So we used the machine learning. It looks at it. It puts it in the right geo coordinates and everything. and brings it real time. Prior to us doing it, it used to take 30 days to manually process that data. Imagine there are 1,000 workers, 500 observations coming in every day, right? So it is complex. So it's boosting the monitoring of the safety and the identification of the safety controls that need to be put in, so risks are mitigated much faster in safety.
Thank you, Abhishek. Please keep that clap going for your next presenter, Josh Sander with Flucto.
Right. In case you're wondering why my shirt is blinding you, I'm a nerd. I'm usually not doing the business aspect of our operation. I just came from that vessel, actually, and I decided to, well, wear something that I'm comfortable with and be seen with. So here I am. Installing an offshore wind farm is hard, really rather quite difficult. But if you think about it, what makes it hard is actually, from my point of view, two things. If you look at that, there's a big vessel, small vessel, there's an operation going on. This is, and I'm just making up this number, this is maybe costing you, let's say, $300,000 every 24 hours. So that's $3.5 every second. So there's a tremendous pressure to not waste any money in a very expensive operation. On the other hand, you have the marine environment, right? So you have wind, you have waves, and because those wind and waves have a heavy impact on your operations, there's very strong limits. And it's inherent to the marine environment that you cannot predict how it's going to be. So while every second you're wasting $3.50, you maybe have to wait for a week for the wind to calm down. Okay, and so where we come in is with monitoring this whole installation and bringing it into a digital world. Let me draw you a picture here. Imagine you're on that vessel. Let's see if that works. And so maybe you have to do this operation. So you're unfortunately the guy who has to call the shots whether you want to proceed with this upending. So this is bringing the monopile from horizontal to vertical. Okay, but you've only been doing that for 2 years. And there's dark clouds in the sky, and the crane is doing funny things, and you have a bit of a bad feeling about this whole thing. So what you used to do in that situation would, take your radio and call in Peter, superintendent's been doing that for 20 odd years. And he'd be telling you, nah, it's gonna be all fine, don't worry, and you proceed. Problem is, Peter has retired. So what do? Well, you get out your phone, you call up the Flucto app, which is our app, and you can see the sensor on the crane tip tells you, nah, the motions are well within the safety margins, and the dark clouds, they're there, but they're going the other way. The latest weather report cleared your operations, so you're good to go, and you proceed. So we provide the basis, the digital basis to, make Peter enjoy his retirement and scale up the installation operations. My name is Josh. I'm the technical guy in our company. We're currently 8. Next slide, please. Yeah, we're based in northern Germany, Bremen. It's a bit of a weird situation with the photo. The thing is, we realized that we didn't have a proper group photo, and when we took one, the guy on the left, Jan, was actually on ski holidays. So that's how that came to be. Anyways, why are we here? Well, we would very much like to penetrate the American market. We would like to become part of offshore installations in the States. So yeah, let's get in touch. Let's talk. Thank you for your attention.
Excellent.
Can you use this in other parts of the installation, like a turbine, these are the foundations?
Yes, we actually started out with a single blade installation because if you think about it, the way how turbines are installed it's mind-boggling because you have a structure that's protruding 150 meters above the sea level, and then you have another structure that's 100 meters long. That's 11 seconds in Usain Bolt's world, right? And you're trying to land that structure with centimeter accuracy, and you're trying to match them. Actually, what we started out with is think park assist for single blade installation. So we started out with sensors that would tell you in real time how your two components would react. And then with our first customer, we there's many aspects to installation. So then now we're currently doing a project on foundation installation.
So I feel like I'm oversimplifying by calling you like a offshore wind weather app. But you've talked a lot about weather and the way that influences the installation. And so is the technology using sensors, or what is the technology here that it is unique?
The primary technology is software. But you have to combine, indeed weather plays a massive role in maritime operations. So you have to combine weather forecasts, real-time measurements, but you also need to know what's happening on the vessel, right? So currently, if they're doing an installation, there is someone with a clipboard who writes down things when they happen. That's the state-of-the-art process, and that's not enough, right? So that's why because there was nothing on the market, we started building sensor boxes, generic sensor boxes that you could put on your different components, and then the actual secret sauce, if you will, is the software that combines it all together. So the measurements from the installation, the weather reports, the wave buoy data, and actually the processes as they're defined in procedures, right? But indeed, if we were to get to the point where it's as simple to use as a weather app, that's actually where I would like to get to.
Hey, Josh. Thanks so much. It's great to see, call it a hard-working shirt on the pitch stage here, so that's wonderful. I'm just curious, so having a simple signal that anyone can use is incredibly valuable, I think, as you think through the repetition of these operations. How do you determine what is within the safety parameter versus what is outside of that safety parameter?
Excellent question. You found our weak point. The point is, as mentioned before, all these operations, every project is unique. So there's some things that you can know beforehand from, let's say, design studies or engineering studies, but there's other things that you simply you have to learn it while you get along. Right? I don't want to oversell it with AI, but in the end, what you're doing is you have to gather that data, and as you gather data, you get better and better at understanding where you go. And I mean, certain aspects of your system are going to be the same over all projects, certain, let's say, turbine characteristics, but others aren't. So this is really, you always have to learn each and every project.
Thank you, Josh. Round of applause for Josh. I do want to remind everyone, we do still have chairs over here. If your legs are getting tired, if you've had a few glasses of wine, you need to sit down, we do have chairs. And now please a round of applause for your next presenter from Arcam Technologies, Jason Cottrell, everybody.
See, is that working? Great. Okay, let's go to the first slide. So yes, I'm Jason Cottrell, the CEO and founder of Arcam Technologies. We are the only company in the world using 3D printing technologies with concrete to manufacture offshore wind turbines. Next slide. So, as you're probably aware, the world is going to install tens of thousands of offshore wind turbines in the near future. A large proportion of those, or a moderate proportion of those, will have to be floating turbines. The reason is that the water is so deep that you cannot use a conventional fixed bottom foundation to reach those water depths. So within the next 10 years, there's going to be 26 gigawatts of floating offshore wind deployed around the world. Those 26 gigawatts are going to need 7,000 anchors. Those 7,000 anchors, believe it or not, will probably cost on the order of $7 billion. So that comes to the problem. There's some problems that most of the anchors are steel anchors. Number one, of course, is high cost, quite expensive. Number two, there's a lot of carbon, CO2, embodied in those anchors. And number three, we presently do not have the supply chain here in New York to manufacture them. So there's a very good chance that both the steel and the anchors will be imported. For example, those three suction anchors at the bottom, and those are people at the bottom there, that is the typical size of a very large wind turbine anchor. Those anchors, if you turn them on the side, you can drive a metro or subway train through those anchors. Every anchor, as I said, costs about $1 million. So let's go to the next slide. So what's our solution? We are providing and offering a portfolio of anchors manufactured from concrete. Those anchors can reduce the costs anywhere between 50% to 80%, depending on which anchor you're selecting compared to steel anchors. And equally importantly, we can make those anchors here in New York with automated printing technologies. We do that with the 3D printing technologies. What it gives you is the ability to eliminate formwork, and it's highly automated. These large printers are able to be operated with, in general, 2 or 3 people, but they also use local materials, concretes that are sourced at the ports effectively. Next slide. So compared to our competition, what do we offer? We offer 1, lower cost, 2, we offer a portfolio of anchors that works for a wide variety of installations, different depths, different soils, including the New York Bight. And we offer local manufacturing, up to 100% domestic content. Next slide. So our team, we have some of the brightest minds in 3D concrete printing in the world working on this project. And equally importantly, we're expanding our engineering staff to accelerate 3D concrete printing and commercialization of these products. Next slide. So what are we doing? So we have the world's only 3D concrete printing system, which is a robotic arm shown there on the left-hand side. We've been using that to manufacture a variety of different types of prototype anchors. We have on the way a large-scale 10-meter printer, which, if we took out this column, would probably fit quite nicely in this room. With that, we can manufacture full-scale printer anchor prototypes. Next slide. So where are we going? Where are we headed? We have substantial funding to do this, and we're headed towards TRL 6 testing, structural testing within the next 2 years. And then the final slide. So thank you. I think with your help and these technologies, we'll be able to bring them here and manufacture these in New York, thereby increasing the number of jobs and local economic benefits for New York. Thank you.
Hi, Jason. Thanks for the presentation. Really great. So I just have a question, not having an engineering background or anything like that. You know, it seems like there's some real positives to kind of adapting this technology. Where is some of the, you know, perhaps kind of hesitancy that you see that's happening that's, you know, that you could help address in allowing this to be more widely adopted?
Yeah, so there's a number of questions we get. Are you using qualified materials? And so that's one thing we have on our commercialization strategy that we're working on. The next question we often get is, you know, concrete doesn't really like tension, so you've got a pad-eye connection. Can your product withstand, how do you withstand those tension loads? And then the third question we often get is, how do you reinforce them? And that's where a lot of the IP lies, in the reinforcement. I mean, that's basically what we're offering, is we've spent years studying how to use this process to solve those challenges effectively.
So I'm maybe not understanding something, but maybe you can help.
Sure.
My understanding is that offshore wind is for very deep ocean floors. We have a shallow ocean floor that's quite flat. I'm not understanding the need for this technology in this geography. So I'm wondering what I'm missing. This sounds to me like you should be working in California rather than New York.
Yes. The initial plants, we're using all the good sites effectively, right? So 30 meters to 50 meters deep. There are some sites today, including those off of Long Beach, that are deeper than 50 meters that monopiles may not work for, which means you have to go into a jacket technology. And then if you look at NYSERDA's plan, they're looking at going deeper and deeper. And so our plan is to develop these technologies as the industry is also going deeper. And I believe we will see floating wind in the New York Bight. I believe we'll see it off the continental shelf, which quickly drops to 1,000 meters, as well as the Central Atlantic and Maine, those locations. So I think it's coming, especially there's other issues associated with noise and monopiles. Floating is silent, right? We use suction buckets. You pump out the water is the loudest noise there. So, and costs are dropping quickly. We just completed a proposal that showed with these technologies, we're looking at if you do this and you print the foundation, a floating foundation, you're looking at LCOE reductions of 20 to 30%. So now that floating is quickly reaching the crossover point with fixed bottom wind.
Good, thank you.
You caught my interest with a description about local New York City-based manufacturing. Can you speak a little bit to the physical requirements that would enable that? We're talking about arms the size of this room. I'd like to know what that size and scale of an operation here could look like.
Yes, so one of the biggest challenges for us has been, one, finding a place to print. So you need a light industrial facility, you need shelter, you probably need some heat during the winter for worker comfort, primarily. So, and you need 480 volt power. That's should be pretty easy to find, but real estate is also very expensive. So if you're a startup, it's not that easy to do, especially if you're trying to find it in a port environment. So, what do we really need is a low-cost, light industrial space near a port environment, because we're going to be printing big printers, right? We're buying that printer because the anchor could be as large as this room and some of the other things as well. And so you need access to the water because you don't want to put this on a truck. So we've done studies on the South Brooklyn terminal. We did this several years ago using now our DC funding before we knew Equinor was going to lease that site. And yeah, it was perfect.
We have other locations. Come and talk to us.
Okay, thank you.
Thank you, Jason. All right, people, we've had a Jason, we've had a Josh, and now we have a Jeff. Please give me a go out for your next presenter, Jeff Knapp and Ideal Power.
Hi, everyone. Thank you for attending. My name is Jeff. I'm with Ideal Power, and I'm going to talk to you about our new power semiconductor switch called B-TRAN. So what's new about B-TRAN? It is inherently bidirectional. It has very low losses. And I'm also going to talk about the future, how we have plans for continued improvements compared to conventional switches with new materials. So we have a long roadmap of continued improvements. So just back to the basics of power switching. Everywhere power conversion happens is generally happening with a semiconductor switch. Everything, AC to DC, DC to AC. The switches that are used now, the conventional switches, are pretty good at it, but they are wasteful, and they give off heat. That is the evidence that they're being wasteful. So if you're charging your phone and you touch the charger, it's hot, that's wasteful. So here, as it comes to offshore wind, we're doing all this work. Everyone's contributing all these important different facets of the system. We finally convert the energy, harness the wind's energy, and we're going to waste it as heat. So we want to minimize that as much as possible, get as much of the energy to where it needs to go. And so B-TRAN is a semiconductor switch. It has three primary advantages. It is bidirectional, where other switches conventionally are unidirectional. it has much lower losses than the traditional switches. And what this leads to is a successful system that is smaller and lower cost. And also, there's nothing exotic about it. We can use the existing supply chain for silicon to get started. So if we look at offshore wind, how does B-TRAN help in offshore wind? These little B-TRANs here represent places that we could help the offshore wind system. Starting with the inverter, we will increase efficiency here by having lower losses. In a bidirectional converter, we improve the system by reducing component count. One B-TRAN will replace 4 chips of a conventional system. Now you'll see these other B-TRAN here and here. Every node in the system can take advantage of a solid-state circuit breaker. Conventional breakers are electromechanical, similar to the breakers in your home. When there's a current surge, boom, they open. A solid-state circuit breaker can be much more efficient, safer, and more reliable, and controllable by software. For example, if you have a weather system that you know is coming in, you don't have to wait for the surge and wait for damage. Very quickly, you could just turn something off if you need to. So those are the advantages that we can bring to the offshore wind. So efficiency, reliability, and safety are where we can improve. This talks about the inverter part of it. So how can we improve the inverter? Traditional inverters right now are voltage source inverters. B-TRAN is a current-driven device, so we could be a solution for a new current source inverter. So why would we use a current source inverter in a wind application? The reason is that the voltage source inverters, the voltage changes over time, and it's not friendly to the motors. It can damage them, it can lower reliability. Where a current source inverter has a very smooth delivery of energy, much more motor friendly, as we say, and more reliable. On the circuit breaker front, the other place we can use B-TRAN, the primary advantage here is what I talked about, replacing 4 chips the traditional way with 1 B-TRAN. In other aspects, we meet all the requirements that are needed for a good breaker. Low conduction losses, we're not wasting energy. Bidirectional. So in our society now, everything is more and more bidirectional, so there's a need for this. To the grid, from the grid, to the battery, from the battery. Everything's going to need to be bidirectional. And most importantly, in a breaker application, very fast. We can open orders of magnitude faster than an electromechanical switch, which leads to safety. We've patented the device itself, the implementation of the device, and some application-specific uses of the device. And we are not resting on our laurels. We have a silicon solution using the existing supply chain. And we have plans for silicon carbide, which you may have heard of, which is still kind of expensive, but as the price comes down, we'll be ready for it, and we're starting that development now.
Jeff, I'm currently reading this book called Chips War, and semiconductors are one of these geopolitical supply chain components that are destabilizing the whole world, from cars to everything, right? And we use them, as you showed, in all sorts of industries. What is your differentiator in terms of how can we avoid that challenge in the supply chain? Can we the key OEMs, turbines, topside, electrical equipment, could they source these components from New York State or from the US? How flexible and adaptable is your product?
Yeah, well, first of all, on a personal note, I'm glad now semiconductors are a household name. My whole career, no one knew what I was doing, but now, because there's a problem, everyone knows about it. So our first funding came from the US Navy. So because of that, our fabs were all US based, all of our packaging is US based. And as far as supply chain, as I mentioned, there's nothing exotic. We can use the existing silicon supply chain. There are fabs in New York being developed with the CHIPS funding. We're trying to learn more about CHIPS funding as well. We're a smaller cog in the system, but as it starts to roll out, we'll be involved in CHIPS as well. And we're also working closely with Stony Brook University to provide system-level expertise, because again, we're a component, so they can help us learn to quantify the improvements. I'm talking about better reliability, better safety. They're going to make a system where we can demonstrate to you and quantify what are the improvements to safety and reliability.
Thanks so much. A couple questions from me. So, total layman, why is it that bidirectional is so important? And would that, for example, reduce the need for, say, grid infrastructure improvements or something of that nature?
Bidirectional was less important in the 90s. Energy was kind of going one way usually with the switches, but now there's an increased grid to this to grid, batteries, so a lot of the energy flow is bidirectional, especially in the circuit breakers. You have to be able to protect in both directions. And the way it's been done up to now is you need 2 unidirectional switches and 2 diodes to protect them anti-parallel. So that's 4 semiconductor chips to make a bidirectional switch. The CTO who developed this realized that he could do it with one device, saw the need for it in the future increasing, and that's how we launched the company, or reformed the company in 2019.
One final question for me, sorry. I'm just curious, could you just describe a little bit your go-to-market and how it is that you landed on offshore wind as an area of interest?
Yes, sure. Well, we started, as soon as the US Navy program validated the concept of the device, we started commercializing right away. So we have a sampling program where we go out to different OEMs, and we're going to touch on all the different categories I showed, and I think it was the second slide, but renewables is an important part of that. We've already had success in automotive, and there are some industrial companies already using us to evaluate for circuit breakers. And in the renewable space, we have multiple ways to enter, so we're looking for an opportunity to show how we could demonstrate a current source inverter and a breaker in offshore wind.
Thank you, Jeff. All right, now I'd like to introduce your next presenter, Eagle Woo and Vinci VR. Keep it going for it.
All right, my name is Eagle Woo with Vinci Virtual Reality. So when President Biden talks a lot about offshore wind, one thing you hear him say over and over again is jobs, jobs, jobs. That's as good as my Biden impression is going to get for tonight, folks. Sorry. Which is great, right? In fact, we're going to create 77,000 new jobs in this country alone in 6 short years. Great news. The problem is there's some risk with that. One, the sheer scale of that is insane. No other industry has to build these many workers in such a short time frame. Second, most Americans have not heard of offshore wind outside of this room. If you go anywhere in the States, most people don't even know what wind power is. In addition, they don't understand what it's like working offshore. Climbing a wind turbine and working 500 feet up in the air, being seasick in the ocean, these are all new concepts for many of our fellow Americans. Lastly, equipment and training is expensive, and also equipment and training is not here. We don't have the infrastructure to train all these workers just about yet. So Vinci is solving this with our virtual reality worker filtering and training library. So we have 2 specific use cases. One, filtering and engaging potential workers to join the offshore wind industry. We're able to do things like simulate seasickness out in the ocean, as well as working at heights. If you don't like heights, it's not a very pleasant experience. And we also have training that's actually certified by international bodies like GLBO, and it's able to be taken in this small little package here and deployable anywhere in the world at any time. We also have multiplayer, so you can have European instructors teaching American workers without having to cross the ocean. So why use our library? 3 key benefits. One, we've shown that our VR training can actually increase hands-on repetition 20 to 30 times more than regular and real equipment. You can filter candidates before training. We have actually seen workers quit their job, like quit the training pipeline, once they climbed up the ladder and they look down, they're like, no, I can't do this. Saves them money. Lastly, lowering the workforce costs. So cranes, even small training cranes can cost as much as $50,000. Nacelles, training nacelles, $5 million and up. Some traction, just to make it clear, it's not just a video game we made. A year ago, we certified 12 union workers working on Vineyard 1 right now with our VR tool. These are some of the workers. They were the first in the world to do so with VR. We also, since then, have launched our software library, and we're on track to hit $600,000 annual recurring revenue by the end of this year with reputable customers like Farmingdale, Tidewater, Vineyard Wind, and recently we just touched down in California as well. our team is both talented, but when it comes to workforce, we also want to make sure it's a diverse and equitable workforce. And for us, it's a very personal matter. Sloan is our creative director. He makes all of our environments. He's an award-winning 3D modeler. He's also a member of the LGBTQ community. Dr. Brown creates content for us. She has a PhD in learning sciences at Georgia Tech, and she's the first black woman to lead Siemens wind training in North America. Since then, she doesn't do that anymore, but it's a reputable title for her. I actually brought a VR headset with me, so if anyone here is brave enough to climb a wind turbine and bear sea states, I'll be right in the back after the pitches with a headset for you to try on. Thank you.
I just want to say I think this is brilliant. I've been waiting for someone to come up with a good use of all that VR stuff. And I was wondering when I read the pre-reading beforehand, if you could simulate seasickness or this height issue, because I thought that was one of the most important things in workforce training. I'm glad that you can do it. I just want to say I think this is great and very necessary.
I too am equally excited about this. Part of me does want to try that after this, but I might need a glass of wine first, or not.
I don't recommend that.
So I'd love to hear a little bit about what brought you to this, to like apply this type of VR experience, experiential learning to offshore wind. And do you do simulations with other sort of like high-risk environments?
Yeah, this is a really good question. So reason we chose offshore wind is it was, well, one, I like video games. I'm a video gamer by heart. It's kind of why I got into this whole thing. I just wanted to make video games, and now I'm here. But we picked offshore wind because it made a lot of sense. I'm personally very passionate about green energy, and realizing that it's like such a big opportunity, but nothing is built. I'm from Massachusetts. Vineyard Wind 1 is the first offshore wind farm being built in the country. And even now today, they've begun construction, and a lot of the training centers are still not set up yet. So it is a very big problem that we identified. And what was your second question again? Sorry.
I'm just curious if you've applied this to other like high-risk activities, construction, or I don't know what other ones I have in mind, but just...
Yeah, so we've applied this to things like aircraft maintenance is one. We're also looking into vessel training. So there's companies that are building all the installation vessels, but nothing is built yet. So a lot of the expertise is in Europe. The question is how can we bring that expertise quickly here? And the idea is to use VR, just connect them to the same space and do training that way.
Yeah.
This is amazing. My question is how you certified 12 Vineyard operators or technicians. How was that possible with the unions, and how was your experience, especially to, a certification, you actually need to validate it with something that is, like a control base. So I'm just curious, how was it? And this could be a game changer for training the next generation as well. Faster, more realistic. I mean, going offshore is, I've been there, is a very dangerous situation, and this is great. Thank you.
Yeah, so it was a 3-year process to do so. It was very long. GLBO is... Sorry.
You're gonna fall off the stage. Okay.
GLBO is a very... for those of you who don't know what GLBO is, just think OSHA, but for wind. It's a very stringent process. We were lucky, and the reason why Cynthia actually is on our team is Cynthia, at her time at Siemens, she made like GLBO courses for Siemens, and she was the one that worked directly with us to make sure that all of our VR simulations were able to hit those regulation guidelines. And it was actually integrated into a Siemens course, and it went through the audits with GLBO. So it took a lot of research, a lot of expertise to develop that. In terms of how do we got the unions, we contacted Mass CEC, contacted Vineyard Wind. We found out who they were hiring from in their PLA, and then we just brought them over to do the training. Siemens sent 12 VR headsets up to the Mass CEC terminal, which was really extraordinary because there's no like equipment there. Like it was just the VR headsets and PowerPoints and the instructors. So the instructors went through the PowerPoints and then they all plopped on the VR headsets and they did the hands-on task from there.
Thank you, Eagle. I'll take that back from you. Okay, we have 2 presenters left. Your next presenter, please welcome Dr. Philip Stratman from Ocean Power Technologies.
Thank you. You've almost made it. So, yes, Philip Stratman. I'm from OPT, Ocean Power Technologies. We work on deploying robots and stationary wave power buoys that are non-grid connected. We have no intention of going grid connected, and use those to do sensing for anything you may want to look for, somewhere between the seabed and the surface and above, be that whales, sharks, mines, whatever comes to mind. We've got about 70 plus of our staff. We're sort of local-ish, wrong side of the Hudson, I know. We're down on the turnpike about 45 minutes south of Newark Airport. Our robotics team is based out of Richmond, California, just north of Berkeley. And then we've got a small team of oil and gas guys that are working out of Houston. I'd say probably almost all of us are ex-military, ex-oil and gas guys. So we've been seasick plenty of times. And I don't think I need to repeat the experience anytime soon. We make all of our stuff here in the United States. And we're very keen on what is happening of the mid-Atlantic shorelines. And we're very keen on figuring out how our tools and technologies can be fed into that. And more importantly, how can we learn what needs to be done out there? Because what we are not is we're not oceanographers, but we're the sort of technologists for the vehicles. So that's kind of the main things we provide. If you think about it, it's an intelligent maritime solution with 0 or low carbon emissions that you can go and do safer pre-construction monitoring. You can figure out what's going out in the ocean. If you've got any UXO, unexploded ordnance that you're dealing with, you can clear that without needing to get Navy divers involved. We can provide you 24/7 access to data without needing to go and send a bunch of grad students out to collect sensors. Plenty of us have done that in the past at some point in our lives as well. And it is real-time data, which is the big thing. The vehicles that we use sort of at the moment come in 3 sizes, 8 foot, 16 foot, and 22 feet. So it's kind of inshore, nearshore, a bit further out. And then the one that you see in that really attractive gray, that's sort of primarily used at the moment as a prototype platform by the US Navy. We just did a 75-hour autonomous excursion in international waters out in Bahrain for the 5th Fleet. So that's sort of some of the developments that we've got going on. The buoy up there, that survived 8 months in the North Sea for what is now Harbour Energy to do exclusion zone monitoring and replace the carbon emissions from what would have previously been a fishing vessel that would have monitored an old decommissioning asset. Down there, that is the Sea of Japan. That was us doing tsunami sensing. And we have a very similar system currently deployed off the coast of Chile to monitor the water-culture impact of aquaculture that is happening near the port of Santiago de Chile. So, as I said, we're the guys with the vehicles and the buoys. The buoys power themselves. Actually, if any of you are interested, it's almost summer season. Get on a boat and go slightly south of Sandy Hook. We have a couple of test beds down there where we go and tow these things in and out so we can constantly figure out what's working and what's not working. But we're not the sensor guys. We don't understand fully what needs to be integrated, how it needs to be integrated. We provide the platform with the power, the edge computing capability, and the cloud platform and the pipes, so you can get your data to where you want it to be and then run it with your team of experts to do the work that needs to be done. We've done work for great white tracking actually with the Wildlife Conservation Society of New York City, where we looked for tagged animals. We do work in the anti-submarine warfare space, and our view is that if we can listen for quiet propellers, we can listen for whale noises. But somebody needs to tell us exactly what hydrophones to use and how to then classify those data sets that we collect. We have cameras at the top, so we can always validate whether what you're hearing is a whale, so you can get much more accurate tracking on your construction downtimes so that you don't have any false alerts or beware any takes that might occur. Thank you.
Thanks for the presentation. That was really great. So you mentioned, you're not oceanographers. I am sort of an oceanographer. So there's a well-cited paper among the kind of marine science ecological community that gets brought up a lot in offshore wind about what's known as drippy data, so data-rich, information poor. So the criticism is that sometimes we go out and collect a lot of data, but it's not very useful because there's no kind of established purpose or hypothesis-driven kind of focus to it. So how do you use your technology to connect to the oceanographers and the subject matter experts to make sure that you're not out collecting a bunch of quote-unquote drippy data?
Yeah, no, I think it's a great question. When the system, as an example, that we've installed of Chile, it's for Enel Green Power. They told us what data they needed for the regulator that they're working with. So we've got an ADCP down there to do wave sensing from the seabed up and correlate to the wave radar. We do turbidity, salinity, we do some chlorophyll data collection for them, currents, and so on and so forth. That is the data that they were told by the regulator they needed, and therefore we configured the sensors in a way that we can give them what they want. We're doing work with NOAA, so we're a member of the Ocean and Coastal Monitoring and Mapping Institute out of UNH, Hui, and Rhode Island. And again, we work on the principle that as long as the sensors and the data that somebody wants to collect fit within our power budget and the water depth that we operate in, and we currently are good for about 10,000 feet because we originally designed it for the oil and gas industry, then we will integrate it and provide it up. We have no incidences of people being concerned about the data because the original surface data collection that we've got was designed for DHS to do illegal fishery interdiction. So it's designed to be able to be used for prosecutorial evidence.
Very interesting technology. This is one of the busiest locations in terms of maritime traffic. If you deploy one of these on top of the water autonomous device, how quickly can it move around? How do you actually control as well, or control it in a way, right?
Well, it's a great question. There's various views what we can do and what we're allowed to do. So Colreg in the US is still very far behind. I think the UK is just certified its first autonomous vehicle to actually operate over the horizon. But we have constant pilot and operator in the loop that we're operating with. We did a survey of Good News Bay in Alaska last year for NOAA, where we're out there for 6 weeks. The carbon savings and the cost savings came from having a much smaller mothership that was out there that then utilized the USVs as opposed to being out there with a massive survey vessel. We've actually done work in New York Harbor underneath the piers in order to save and de-risk diver operations. The way we would look at this is constantly work with the local authorities to kind of figure out, okay, here's what we can do, here's where this thing is going to be. On the buoys, it's a little bit easier because Coast Guard considers them to be aid to navigation, and because we're not grid connected, we don't have any cables that go along the seabed.
Thank you so much. All right, we have one more presenter for you. Please welcome your final presenter of the evening from Benchmark Labs, Elric Straderson.
I'll give it a C+, but it's pretty good. Thank you all for having us, and thank you to the panels and the other great companies here. Congratulations, you've made it. This is the last one. We are, in fact, in many ways, a weather app. I'm with Benchmark Labs. Let's see if we can do it here. Thank you. I am the Chief Operations Officer with Benchmark Labs and a co-founder. To the right here, or stage left, is our CEO, who's an accomplished PhD atmospheric scientist as well. We are a minority-led and owned company, which we are also very proud of. It's within the fabric, although I may not represent it the best. So there are many use cases for weather within wind turbine process for installation, for operations management, and the like. Today I'm going to primarily focus on that last piece, the operations and management, where there's significant loss and production due to wind speeds and maritime crews that need to go out to these installations safely and effectively to be able to do repairs. These wind turbines are often down up to 5 to 20% of the time, and these crews cannot go out effectively to complete those repairs. The problem is there's not effective weather data because of how we've done weather modeling for the last 80 years or so, where the National Weather Services all over the world, they divide the world into boxes like around a Rubik's Cube, and everyone in each box gets exactly the same weather forecast, regardless of their microclimate. And this is a totally non-local approach. If you look into these boxes, there's a number of microclimates on and offshore. And so having a weather forecast for Brooklyn works reasonably well if you're wondering if it's going to rain today. It works pretty poorly if you're the manager of a fixed asset like a wind turbine, and you need to know how much energy it's producing, what is happening at that turbine, can I go out to do repairs, and the like. How we do this, we are a software company. We tie into any existing hardware, IoT sensors that are out in the field. So this could be weather sensors that are at the port. This could be smart buoys that are going up to the turbine. This could be the turbine itself, which is the world's biggest anemometer in many ways. We take that data, then we take the gridded data from the National Weather Service, from IBM, the weather company, AccuWeather, and the like, and then we correct that large-scale forecast to that specific point using machine learning and a series of physical models as well. Oh, thank you. And we reduce the error up to 85%, or another way of thinking about that is our 7-day forecast is 3 times as skillful as the 24-hour forecast from the National Weather Service, which has been validated with the Nature Conservancy and other use cases as well. We're quite proud of our performance, and you can pull our forecast as well as other companies' forecast from our API and do these comparisons yourself. Thank you. We are a SaaS company. It's an annual subscription for each device. So if you have multiple buoys around your wind turbines, each one of those buoys would receive its own individual forecast. Each turbine would receive its own forecast and the like. So today, turbines are down 5 to 20% of the time. The farther a turbine is out from shore, the more it tends to be down, and that is due to minor repairs in many cases, and yet these crews can only go out in very specific weather conditions, especially with the periods of the waves out at sea. Perfect. And so they are restricted to these access windows where they have to transit from the turbine, and in some cases you'll see these amazing photos of folks kind of jumping from a crane to the turbine, and it is quite exciting to watch. And we can collaborate with a lot of the different companies here today in their operations, providing better weather data. So I will pause there. Thank you.
Exciting. I have a question for you. So I'm curious if, as a user, you are only able to monitor the weather on your equipment based on the sensors that you sort of install in your farm, in your wind area, versus are you creating like an interconnected system where I'm able to get data outside of maybe my own holdings so that I'm able to do more like predictive analytics about what might be coming my way?
Yeah, excellent question. So our primary focus is serving a forecast to each individual sensor, and the owners of those sensors own the data coming from those sensors. So if the data from those sensors, or the buoys in many cases, are public, then we can absolutely offer forecasts for those. And we've done that for other industries where we look at, the Fawn network in Florida. It's got 120 sensors, and there's lots of farmers and burn practitioners nearby that sensor that would like a much better forecast. And so we can absolutely provide forecasts for any of the NOAA buoys, for instance, that are out there now, or if the Navy would like to share their data, we can provide forecasts to those as well.
Thank you.
Hey, thanks so much. I have another two-part question, so sorry about that. First, I often hear from, call it internal stakeholders or other folks in the ecosystem, well, our data is good enough. What is the true value proposition for being able to predict these things down to a microclimate at a specific time period?
Absolutely, great question. And the answer is in many cases that 85% reduction in root mean square error for offshore wind farms. That is the difference between your wind turbine being down for could be multiple days because you're not able to send a repair crew out because you do not reliably know what the wave conditions are out at sea. And so that can increase, in this case, your production up to 20% at each individual wind farm, which is, of course, millions of dollars. And it's not directly linear, of course, as you're suggesting, between the weather performance and the performance getting to that 20%. It's probably, 50-50, where 50% of the performance increase on the weather will unlock that full 20% or 19%.
Great. And then my second question. So I led tonight saying I think it's really important we be collaborative to accelerate the transition here. And one of the things that I find really interesting about your approach is you're leveraging the sensors that are already out there. So I'm just curious, how are you actively collaborating with, call it the OEMs or other startups in the ecosystem to develop a higher resolution forecast?
Yeah, great question. So, and this is one of the big reasons that we exist. So today, in agriculture, for instance, there's 22 million IoT weather sensors deployed globally. Those weather sensors are getting current state data and tracking historical trends. They don't receive forecasts. And it's in part because we haven't had 5G or Starlink until now, and we can't get real live data feeds, and our satellites have lag based on the atmosphere and cloud cover and the like. And so today, now we can partner with any of those hardware companies. There are channel partners, so they co-sell our forecasts alongside their sensors. I think 9 out of the 11 companies today, I saw some synergy where we can integrate in with their application, just provide better weather forecasts and improve their processes. Yeah. It's a big part of our go-to-market.
Thank you so much. That was the last and final pitch of your night. You all made it. Please give all our finalists a last warm hand. Thank you. I will truly leave this evening sort of inspired, encouraged, electrified. But we will keep the suspense a few more weeks before we will let you all know who makes it into our final cohort. So please bear with us a little more before we make that public. But thank you so much for coming tonight. Before I'm gonna leave you to mingle and get all the refreshments, I do wanna say a major thank you to the best team in the entire world. Alex, Julia, Meg, Rachel, Crystal, Ria, wherever you are. Without this, there would be no Offshore Wind Innovation Hub, there would be no event tonight. So please give them a warm, warm hand. Yay. And of course, there would be no program without our amazing partners. These are, of course, Equinor, BP, the Offshore Wind National Research and Development Consortium. It is the EDC, and it is, of course, the NYU Tandon School of Engineering and the Urban Future Lab. So thank you to our judges. Yay! And with that, it's been a really, really great pleasure having you all here. We look forward to be connected with all of you in the future. Have some drinks, have some food, and thank you for joining us tonight. Thank you.